Hello, Abyss. Welcome to, what class is this? AP Calculus. Thank you. Sometimes I get confused. Is equal to g of x. We're doing a little bit of review right now. And so I would make this little triangle. It's supposed to be a right triangle. G of x would be here. 1 would be here. The square root of 1 minus g of x squared would be right here. I would take the derivative. I would get the derivative of sine is cosine of y. Because I have a y in here, I have to take the derivative of it, which is dy dx. Over here I would get g prime of x. And that means dy dx is g prime of x over the cosine of y. And cosine is adjacent over hypotenuse. So dy dx is equal to g prime of x over the square root of 1 minus g of x squared. That's the shortcut, correct? Going from here to here is the shortcut. But you don't have to do it. You go through that process the whole time, correct? Here's an example. Here's what g of x is. It's x squared. Let me make it up a little bit bigger here. It's x squared over 5. So if I take its derivative is going to be on top. It's going to be 2/5 x. That's g prime of x right here. Down here, I put in g of x. Let me get this so I'm lining it up correctly. I put g of x in here and I squared it, and that's where I get x to the 4th over 25. Everybody all right on that? No? Right here, here's g of x squared. Here's g of x squared right there. Okay. So then what I did is here's 2x over 5. I got a common denominator. 1 is 25 over 25 minus x to the 4th over 25. And I got this. Well, I could break that up as the square root of 25 minus x to the 4th over the square root of 25. And the square root of 25 is 5. That's what this is right here. So it simplifies to this. And if you take a look at this x to the 4th, and I wrote it as x squared squared, the derivative of x squared is 2x. So I'm saying there's a relationship between this denominator and this numerator. All right, now, why do I bring that up? Well, first of all, we're going to kind of do the shortcut method a couple of times. I'm going to do that first, and then I'm going to tell you why I'm going to bring that up. So if I follow this, I would write on top the derivative, which is 3x squared over 16. And then down here I would have 1 minus x to the 6 over 256. X cubed squared is x to the 6th. 16 squared is 256. And this could be written as 3x squared over 16 times the square root of 256 minus x to the 6 over the square root of 256. So again, what did I do? I got a common denominator, 256 over 256 minus x to the 6 over 256. Then wrote it like this. The square root of 256 is 16. So I'm left with this, 3x squared over the square root of 256 minus x to the sixth. And if I look at x to the sixth, it is x cubed squared, and the square root of x cubed is 3x squared. Yes, ma'am.
Why do you do the square root of 256? Where do you get that from? I know where you get it from, but why do you?
So I get rid of this 16. It's in the simpler form. Because what I have here, I have what's called an improper fraction, a mixed, in that, not an infraction, it's a complex fraction. Because I have a fraction up here, I have a fraction in my radical, and so what I'm trying to do is simplify them so I have no fractions at all inside either the numerator or the denominator. Okay? It's what we define as simplest form. So what I'm trying to get to is, even if I have something in simplest form, I have a way to determine what the antiderivative is. Okay? And what I'm trying to say, one of the hints I can find what the antiderivative is by taking what I call the square root, which is x cubed in this case, and looking, its derivative exists on top. Okay? That's kind of where I'm headed. Because everything you see as an answer is going to be in simplest form. Correct? It is a derivative that's been put in simplest form. What was the antiderivative that I started out with? Thank you. Okay? I'm going to do this one more time. This is the same as the arc sine of 3x to the fifth over 1. And I'm going to take the derivative again using the shortcut. And it's going to be 15x to the fourth over the square root of 1 minus 9x to the 10th. Now, what did I do? I put the derivative of this function on top, and it's 1 minus that squared. So what I'm doing is I'm skipping the triangle part. Now, I don't have to simplify this because everything, there are no fractions, correct? So I would just leave it like that. But what I'm trying to tell you is that I could write it this way. That's really 1 squared. This is really 3x to the fifth squared, and there's that derivative. I'm just trying to point out a pattern. Okay? And so the simplest forms that we're going to have is we're only going to have 3 of them. And like I said, I'm going to give you a piece of paper, if you choose to, that will have all 3 of these. Just 3. And I'll tell you why just 3 in a second. So I don't particularly like this form. I usually write it so it looks like this. G prime of x up here, square root of a squared minus g of x squared dx. If I see anything that looks like that form, it is the arc sine of g of x over a plus c. This again I rewrite. I'm going to rewrite it so it looks like this. I write g prime of x here. Notice there's no square root. It's a squared plus g of x, that quantity squared, times d of x. If I see anything that's in this form, I know I could rewrite it as 1 over a, the tangent of g of x over a plus c. Pardon?
Arctangent?
Yeah, thank you, arctangent. I'll write tangent inverse. That's all I'll say myself. Hi, how long you been here?
A couple minutes.
Couple minutes?
Feels like.
She's not here.
Oh, she's not. Okay.
Yeah. Oh, that's sad. All right, this last one, again, I can write it so it looks like this. This is going to be g of x here. Excuse me, this is going to be g prime of x. Square root of g of x squared minus a squared is equal to 1 over a times the arc secant of the absolute value of g of x over a plus c. Now, on the test, you're only going to get one of these. If I had to pick probabilities, which one you would get, it'll either be 97.5% this, 97.5% this. I'm not a big fan of secant, so 30% chance of this. Now, why are there no antiderivatives for arc cosine, arc cotangent, and arc cosecant? Because this is the negative of arc sine. So we just write arc sine with a negative symbol in front of it. This is the negative of arc tangent. And this is just the negative of arc secant. So those are the only three we need to know. Now, a couple other things. Only arc secant and only arc sine have square roots. Arc tangent never has a square root. The difference between arc sine and arc secant is, for one, you have a constant minus a function in arc sine. In arc secant, you have a function minus a constant inside the square root, and you need that function out front. It's more complicated. We'll look at some examples in a bit. All right. Thank you for your patience, by the way. So let's say I get a problem like this. The first thing I would do is I always write it in this form. That's the first thing I do. And the first thing I try to do when I see an exponent other than a negative 1, I think about reversing the power rule. By that, I'm thinking about adding 1, getting a half, multiplying the front by a 2, which is its reciprocal, keeping this inside and adding c. And then I'd be done. It's a lot less work. For me to do that, the derivative, right, because this has parentheses, there must have been the chain rule to create this derivative. I'd have to have a negative 2x. It's not there, is it? So I can't reverse the chain rule. And because I can't reverse the chain rule, I'm thinking it's one either arc sine, arc tangent, or arc secant. I'll say it again. Because there's no negative 2x, I'm thinking it's one, either arc sine, arc tangent, arc secant. Secondly, because there's a square root, I know it's not arc tangent. Everybody with me on that? So what I'm going to do is I'm going to rewrite it so it looks like this. I'm going to write 2 squared minus x squared dx. And I've created parentheses here. In other words, I'm saying g of x, my function, is x. And the derivative of that would be what? 1. Notice it's here, isn't it? So for sure, it's either arcsine or arcsecant. A is going to be 2. It's always the square root of that number. And since it's a squared minus g of x squared, it has to be arcsine. So my answer is going to be arcsine of g of x, which is x, over a, which is 2, plus c. I'm going to check. How can I check? Well, I'm going to make a little right triangle. I'm going to call this y. I'm going to say that the sine of y equals x over 2. This is going to be x. This is going to be 2. I'm going to apply the Pythagorean theorem. I'm going to get 4 minus x squared, correct? Is that in my integral? It is. So I solved it correctly. Jacob.
Couldn't it be arcsecant too, because the g of x out front would just be 1?
No, what would have to be, first of all, for it to be arcsecant, these two would have to be switched.
Oh, yeah.
And what needs to be out front is an x.
Oh, yeah. Right.
These need to be identical, and that's not what I have. Okay? So the function squared comes first, minus the constant, and we'll see one like it in a bit. And what has to happen is this function has to be in front of the square root. Okay? Kind of like the next one. Okay. Not the next one. Now, again, I'm going to rewrite it so it looks like this. Now, I'm thinking natural log. Why? I got a fraction. My exponent is a 1 in the denominator, which means I have a negative 1. I look to see whether the derivative of this is on top. Is 18x there? It's not, is it? So that means it's one of the arc-trig functions. It's got to be arctangent because there's no square root. So I'm going to rewrite it so it looks like this. The square root of 2 squared plus 3x squared dx. So I'm thinking g of x equals 3x. Its derivative better be what? 3. And I don't have a 3 here. But I've learned how to fix that. I multiply by 3. I multiply by a 1/3 out here, correct? And a is equal to the square root of 2. So if you look at, it's going to be 1 over a, 1 over the square root of 2, times the arctangent of 3x over the square root of 2 plus c. Yes, ma'am.
What happens to the 1/3?
It's 1/3 times, and so it's 1. You know what? I was thinking, yes, I did this without making a mistake, and lo and behold, I forgot the 1/3 plus c. Okay, so Jacob, here's one that you were talking about before. Looks a little different, right? So over here I got a 1. I mean, I would need an 8x up here. Not only do I have an 8x, not an 8x up here, I got this x down here, don't I? So I'm going to put a 1 there. I'm going to put my dx here. I'm going to put an x. I'm going to write the square root. I'm going to write 2x squared minus 3 squared. What needs to be here is a 2x. What needs to be up here is a 2. Well, this is pretty nice. I can multiply by 2 and divide by 2. I satisfied both, didn't I? G of x is equal to 2x. G prime of x is equal to 2.
You're off the screen.
A is equal to 3. And I'm not going to multiply by 1/2. I needed both of these 2's. But in the simplification process, I would have canceled them out with a red pen, right? I'm just bringing them back now. Does that kind of make sense? So that means I have 1/3, 1 over a, times the arc secant of the absolute value of 2x over 3 plus c. Again, can I move to number 4 or am I going too fast? Okay. Michael's giving me the thumbs up. Hopefully that means okay. Now, again, the way I would start out is I would first look at this. E the 2x minus 1, the negative 1/2 dx, reverse the power rule, but I would need to have the derivative of this over here. I would need 2e to the 2x, wouldn't I? Right? I don't have it. So what I'm going to do is I'm going to write this. So again, I'm thinking arc sine or arc secant. Do you notice why I don't say arc tangent? So I'm going to have this. I got 1. I got dx. I got the square root. I got e to the x squared minus 1. Jacob, it looks like it should be arc secant, right? Because I got the function first and then a constant next, correct? And I can't switch them in subtraction, can I? Subtraction cannot be 3 minus 2 is not the same as 2 minus 3. What I need up here is the derivative. Now, e to the x is special because it's its own derivative. So if I put e of the x up here, I can't do that unless I put an e of the x there. Is that okay to do? Yeah, because that's 1, isn't it? That is the only time I introduce a function, because e of the x is special. It's its own derivative, and if I put it on top, I better put it on the bottom. Well, now it's in the right form, isn't it? In other words, g of x is equal to e of the x, g prime of x is equal to e of the x, and a is equal to 1. So what does that give me? That gives me 1 over 1 times the arc secant of the absolute value of e of the x, which is dumb because it's always positive, over 1 plus c, or the arc secant of e of the x plus c. All right, doing okay? All right, now, again, I look to see if the derivative of this is on top. What is the derivative of this? Logan Stockinger, can I ask you? Is that okay? What is the derivative of 4 minus x squared? Just 4 minus x squared.
2x.
Close, real close. Negative, yeah, and it's not, is it? And no way is it x plus 2 even. So what I'm going to do is I'm going to break it up so it looks like this. And I can do that because this fraction is the result of adding two fractions with a common denominator. Are we okay with that? Ben, they're going to be integrated differently. And what I'm going to do is I'm going to take this and I'm going to do one more thing. I'm going to write it like this. Do you see why I did that? Because the derivative of this is that, isn't it? Now I'm coming back here and I'm going to rewrite this one so it looks like this. I'm going to put the x dx like that, and I'm going to write 4 minus x squared to the negative 1/2. Are you okay with that, Logan Stockinger? That's a terrible negative symbol. I'll make it better. You okay with that? Okay, now you said the derivative was a negative 2x, correct? Right? I got the x. What am I missing? So I'm going to put in a negative 2 here, but then I can have a negative 1/2. So now, this is not arc anything, is it? Because the derivative of this quantity exists right there, isn't it? It was created from the chain rule. And since this has an exponent other than a negative 1, I can reverse the power rule. So I'm going to get 4 minus x squared. I'm going to add 1 to this, get a half. I'm going to multiply by the reciprocal, which is 2. And before anybody yells at me, I already know there's a negative 1/2 right there. So this is going to be a negative square root of 4 minus x squared plus 2 times something here. Well, this is arc something, isn't it? The reason it's arc something is because the derivative of that is here. Arc what? It's not arc secant, is it? It's not arc tangent simply because it has a square root. So arc sine says g of x will go on top, a will go on the bottom. There's my 2 right there, plus c. So the reason I brought these up is take a look. The denominators are the same. The antiderivatives are done 2 totally different ways. All right. I'm going to flip the page. Review. Completing the square. Do you remember completing the square? How many people find that a painful process? Okay, I'm going to try to make it less painful. Braden? Follow a painful process. Ready? I'm going to show you. You know what that is? It's a square.
It's a rhombus.
Okay? You see these check marks over in geometry? Okay, you know what that is?
It's a parallelogram.
No, more specifically. It's a rectangle, correct? So this is what I do, is every beginning of every school year, we're here a week before you guys are. It's called Workshop Week. And they teach us stuff. They do. And they use my room. Okay. And so what I do is when all the teachers come in from throughout the district, they come in here, I hand them little postcards. And I just ask one question. On the desk you're sitting at, the top of the desk is what shape? Just see if they know the answer. 50% of them say square. %50 of them say square. Then I throw them a basketball. What shape is this? 75% say that's a circle. This is a rectangle. Okay? And technically, that's not a rectangle either because the corners are curved. They're not at 90-degree angles. Norm would not be happy with that. Okay? So, this rectangle is x squared plus 6x. I don't know if you ever saw this. You ever see this where this is x plus this? That's x. You've never seen that? Really? You've never seen this, x times x plus 6, width by, base times length times width, whatever, and you distribute and get that? Now I'm going to complete the square. Well, okay, let's back up a little bit, because my guess is you guys forgot this. X plus 1 times x plus 1. You won't write x squared plus 1, correct? Because you would get a voodoo stamp? Anybody out there? You get x squared plus 2x plus 1 because the inner and the outer are the same. This is called a binomial square. This is called a trinomial square. They're the same square. In other words, this is x plus 1. This is x plus 1. Okay? Now, if I'm going to complete the square here, I take half of this, which is 3, because I got two 3x's, don't I? Right? The outside's 3x, the inside's 3x. And to complete it, I'd have to add 9. Correct? How did I get that? I squared 9. But I got to subtract 9. Because I started out with this. It'd be like this. I come home today. My wife says, oh my God, because we have cupcakes because it's Mrs. Benson's birthday. So when I'll come home today, she'll say, you've gained 9 pounds today. Why? Because I'll look fatter. But if I gained 9 pounds and was able to lose the 9 pounds before I came home, she couldn't tell the difference, correct? That's this. So now I could write it like this. Right? You remembering any of this? Which is the same as this. There's a reason I want to write it like that in a bit. Matt, you've been feeling ill. Can I call on you?
You can call me, probably.
Okay. I want to see if you can complete the square for me, okay? Ready? What do you think?
25.
And then what, followed by a?
Negative 25. Or subtract.
Yep, that's fine.
X plus 5 minus 5 squared.
perfect. You did a wonderful job. That's all I'm looking for. Okay? Okay. What do? I put that 13 over here. Don't want it. Some people use it. I don't like it. So what would I put in here? Half of 12 is 6. 6 squared is what? 36. I'd have to subtract 36 here, correct? And so I'd have x plus 6 squared minus, what, 23? Does that look right? And if I wanted to, I could do this. Is this not too bad? Okay, let's try this one. Guys are going, oh, he's making it hard. I knew he'd make it hard. I knew he'd make it hard. I knew he'd make it hard. So this is what I'm going to do. Right, it would be a minus 14x. Jack, what would I add here?
49.
Plus 49, right? Do I subtract 49?
Will it become additions?
It's going to be a plus 49, right? Because really that's a negative x squared. That's really a plus 14x. And that's really a minus 49, correct? So I could write this as 7 squared minus x minus 7 squared. Would you agree? That's as complicated as completing the square that you have to do. Are you okay with that? That's all you got to do for me, all right? So now let's take a look at this. If I took the derivative of this, I'd go like this right away, raise to the first power. I'm thinking natural log, correct? But just because I put the 1 there, I'm thinking natural log. Not reversing the power rule, natural log. Because I can't add negative 1 plus 1. That gives me 0. Because now I'm dividing by 0, correct? So I'm thinking natural log. Except I need 2x minus 4 up here. And I don't have it. So it's got to be an arc something. And Katie, I'm thinking arc tangent because there's no square root. So I'm going to complete the square. Because I need that g of x squared. So I'm going to write this down. X squared minus 4x. And I'm going to write, well actually, yeah, I'll do it right here. What would I add here? To complete it, what would have to be here? A plus what? Plus 4. Do you see why I get a plus 3 here? Are you okay? I did a little differently. Or if you want, I could do this. Maybe this would make you feel better. Does that make you feel a little better? This right here is what? 3. There's that 3 right here. Are you okay now? And so now I'm going to write this. 1 over x minus 2 squared plus the square root of 3 squared dx. Look at this. What is the derivative of x minus 2? is at 1. So g of x equals x minus 2. G prime of x is equal to 1. A is equal to the square root of 3. So it's going to be arc, 1 over the square root of 3, arc tangent of x minus 2 over the square root of 3 plus c. All right, last one. Again, I'm figuring out the area underneath this curve right here. This is a definite integral. It's got an a, it's got a b. It's got hat and boots, correct? No plus c, correct? No plus c. And so I'm thinking of reversing the power rule because the exponent down here is a half, correct? That's what I'm thinking. So I take a look up here and I need a derivative of 3 minus 2x, which I don't have, do I? So now I'm thinking, all right, it's arc sine or arc secant. Would you agree? So now over here on the right, because it's kind of messy, I'm just going to complete this square. And I write it in that form. I factor out the minus sign. X squared minus 3x plus, well, what's half of a minus 3? A negative 1.5, correct? Squared is 2.25. What will I write here? Plus 2.25. In other words, it's 2.25 minus parentheses x minus 1.5 squared. Are you guys all right in that transition from here to here? This, when I double it, should be this. When I square it, should be that. This is going to be 1.5 squared minus x minus 1.5 squared. So now when I come back here, I can rewrite this so it is integrating from 1.5 to 2.25. 1 over the square root of 1.5 squared minus the function x minus 1.5 squared dx. The derivative of this is 1. A is equal to 1.5. G of x is equal to x minus 1.5. Isabel, I'm going to call on you. Is it arctangent? No. Okay. So it's either arcsine or arcsecant, correct? Which one do you think it is? Do you see why I like arcsine? It's simpler, right? It'd be nice if everything was arcsine. But you got that arcsecant that just kind of is out there to mess with you. Okay? But there's nothing in here. Here's a, right? It's in the form of a constant minus a function squared. So that means it's going to be arc sine. And I like, you know, here's another reason, Isabel, I like arc sine. I always forget on arctangent to put 1 over a. I always forget on arcsecant to put 1 over a. You know, like what I like about sine? I can forget it. And over here I'm going to have x minus 1.5 over a, which is 1.5, evaluated from 1.5 to 2.25. So now I have the arc sine of 2.25 minus 1.5 over 1.5, because that's the antiderivative, minus the arc sine of 1.5 minus 1.5 divided by 1.5. You used your calculator already? No? Did you take 2.25 and subtract 1.5? No? Okay, let me ask you this. $2.25 minus $1.50. 3/4, 75 cents, right? You don't do change. You leave a tip then. Okay, good. So, do you see where I get 0.75 over 1.5? What does that simplify to? 0.75 is how much of 1.5? A half. So this is the arc sine of a half minus the arc sine of 0. All right, here's the hard part. And I'm having such a good day. What angle measurement, right? That's a ratio. What angle measurement, the sine of what is a half? See, this is the kind of stuff you don't get to use a calculator on. The sine of what is a half? Give a hint. It's got pi in it. That's why I like trig, because I like pi. Pi over what? Well, your choices are pi over 6, pi over 3, pi over 4, pi over 2, pi over 6. Minus the arc sine of 0. 0. And your answer is pi over 6. Tomorrow's a work day. Maria?
Yes.
It is a work day.
Is it a real work day or do we have a pop quiz?
It is a real work day. Except for somebody, Destiny, she's got to get her picture taken. She doesn't know it yet, unless she was supposed to get taken today. Who
We
knows?
need to get our picture taken right now.
Yeah, we have to put on standards.
Oh, do we have time?
Yeah, 10 minutes.
Just wait here.